Alright guys, this is we got 3 cosine 1/4 x, and then should be 4 sine 4x. And basically what I did was I looked at the very top and bottom, found that distance between them, which ended up being, you know what, I did this one wrong, didn't I? Anybody gets, this should not be there, should it? This should be a distance of how much, guys? What is it? How far up does it go? To what? 5. How far down does it go? -5 for a distance of 10. So this should be A is equal to what? 5, which means I need to fix that there. Sorry, guys. So you find the distance from the very top, from the max to the min, you divide it by 2, there's your amplitude. It doesn't matter if it's shift, up, down, left, it doesn't matter, whatever. As long as you find the distance from the top to the bottom, subtract them. So if we were to find that 10, it would be -5 minus 5. And you get that distance, and it's the absolute value of it, which should give you positive 10. Because we are talking about distance, guys. So it's 10, and you take that and divide it by 2, and you end up with your amplitude. The next thing was you have to find the start and stop point. Well, typically when we're looking at you writing graphs, you want to go ahead and figure out, okay, if I was to every time try to start at the y-axis. Well, at the y-axis, we start at the max there. So what trig function starts at the max? Cosine, perfect. So we're at the cosine. And you go along the x-axis, looking at that graph, following the graph till it goes back up to where it started again. That tells you the period. So from 0 to 8 pi is where it starts and stops. So you find that distance, and of course, to find period is 2 pi over b. That's what we did. And you guys had an equation, and you plugged it into the equation from there. This is kind of backwards. They're giving you that cycle length, and you've got to solve for b. So 2 pi over b is equal to 8 pi here. So you solve, and you end up with 1/4. So that gives you the equation of 5 cosine 1/4 x. Over here, amplitude, distance from top to bottom is a total of 8. Divided by 2 gives you 4. Then from there, you find from start, well, we here start at the origin. The next time we come back for a full cycle and come back to the origin is at pi over 2. So 2 pi over b is equal to pi over 2. Cross, divide, solve, and you get b is equal to 4. So then you end up with your equation, 4 sine 4x. And that's how you come up with the equation from the graph. Okay? Kind of backwards from what we saw yesterday, but that's the same idea. Okay, so let's go ahead and now dive into tangent and cotangent. Before we do that, however, let's go ahead and look at some points that are on the graph that's going to help us along here, okay? So when we first start off at 0 degrees here, what is the coordinates of that point, guys? 0, close. Common mistake. It's 50-50, and usually you think of everybody getting it wrong most of the time, it's usually 75-25, but 1, 0. What about halfway through? What's the coordinates halfway through, guys? Halfway. What's 45 degrees? What's at the top? What ends up being the next? We are in quadrant 2, so what? Negative. Positive. And then what? Good. They're both negative, right? And then and there you go. Alright, so those points are important because you're about to see why in just a moment. When you find tangent, guys, what does tangent break down as? What all ways have you interpreted tangent? What? Tangent. Let's go back to when you first started trig functions in geometry. What did you say tangent was? Opposite over adjacent. TOA. Opposite over adjacent. So then we went ahead and fast forward now to pre-cal, and we start talking about opposite and adjacent. Now ends up being y and x. Opposite is the y distance. Adjacent is the x distance. So now we're looking at y over x. Then we went ahead and talked about y and x and how that translates to certain trig functions. What trig function corresponds with the y values? Sine. Good. So tangent now turns into sine x over cosine x. Or if you like, guys, what you were talking about earlier, it's perfectly fine, is y divided by x. I'd write that out to the side as well. So let's talk about the trig function for just a moment. Well, for sine and cosine, it was pretty simple because for sine and cosine, we could put any angle in and always get a certain value. You knew that because you just plugged it into the square root trick and you end up getting some answer and everything was fine. But now we have problems with tangent because tangent is actually a fraction. You see y over x? Where could that cause problems? What's problems with fractions, guys? That could be problems because you can get confused about what sign goes to where. That's true. What else? How do we have rules? Yeah. We could have the denominator equal 0. And as we've talked about before here, is if the denominator is 0, you're asking the question, what number do I multiply times 0 to get the numerator? Which could never happen. So then, what Aiden pointed out is there could be holes, or in graphs, we're going to call them asymptotes. You guys have heard about asymptotes before. You've seen them in rational functions because that's when we had the denominator equals 0. So now we look at this and say, okay, where does x equal 0? Where does x equal 0 as we're going around the unit circle, guys? Pi over 2, and where else? Yep. Pi over 2. So here, well, I should make it in red. And 3 pi over 2, which is actually off the graph, so we don't have to worry about it, but I do want to label from pi over 2 to pi over 2, there is an asymptote. Because at that point, x equals 0, which means the denominator equals 0, which means it's no solution. So then we go, okay, what happens in between? Well, look in between all of those coordinates, guys. Because what's right in the middle of each quadrant? What do you notice about the coordinates that are in the middle of each quadrant that I had y'all fill in? Anybody? What is a characteristic about those two coordinates? There's 2. What about those 2? They are the same. Remember, guys, tangent is y divided by x. So what do you think something divided by its same self is equal to? 1. So that tells you at every 45 degrees, or in the middle of a quadrant, you're going to get 1 or negative 1 every time. So I come over here into this graph, and as you can look here, guys, this represents where we start. This represents 0 radians. This represents right here pi over 2 radians. So in the middle of it is going to be a positive 1. You follow me? It's a little bit off. I don't like tangent very much because tangent doesn't really start in a nice, easy spot. Tangent, you kind of start, if you're starting here, you start in the middle. I'll be honest with you. You start in the middle of the graph. It looks weird. So, with this, let's go back. What is the tangent of 0? Well, look at those coordinates. What is the tangent of 0? Well, what is 0 divided by 1? Hey, tangent, just like sine, goes through the origin as well. Tangent, just like sine, goes through the origin. So this represents quadrant 1. This would represent quadrant 2. Out here would represent quadrant 3. And unfortunately it wraps around because it's a cycle. This is quadrant 4. What do you notice if I divide those two coordinates together? What do I get? So as you can see here, we have it going through the origin. It goes up and over 1, and goes down and over 1. And we have asymptotes. So in order to draw this, it looks like a twist. And the steepness of that twist is dependent on the amplitude. Because if there is a 5 in front of tangent, right here, that would not be circled at 1, it would be all the way up to 5. These two would be spread out even further because the amplitude, what? It stretches. The amplitude stretches it. So the good inclination of where it should go is those two dots there. However, if there's no horizontal or vertical shift, tangent will always go through the origin. So that's why this looks weird, guys, because if I was to draw this from first quadrant to second quadrant, from start to finish, like we've done sine and cosine, it would look like this. And I don't want you to do this, I just want you to watch. That's what tangent really looks like. However, it's really hard to see that sometimes. So that's why you'll always see me draw tangents like that. Tangent is going to go through the origin, and it's increasing, guys. It is increasing from left to right. It is going up. Okay? Good so far? Okay. So now let's look at cotangent. And what do we know about the relationship between tangent and cotangent? Inverse, or it flips. Reciprocal, right? So that means now we're not looking at y over x. We are looking at x over y. So then we start asking the questions, well, where are the asymptotes for cotangent function? Well, where is y equal to 0? Where is y? Going around that circle to the left there, where is y equal to 0? The x-axis, right? The x-axis. So we have an asymptote at 0 radians and at pi. Now I like cotangents better because you actually start, if you're starting from where you need to start, you're starting at an asymptote. You're going to have this function actually going to look like it has a start and a stop place. That makes sense. So let me ask you this. In between 0 radians and pi, what is right in between it? What measurement is that? Pi over 2. What's the coordinates of pi over 2? 0, 1. So let me ask you, if it's 0, 1, what is it? Write that 0, 1. If it's x over y, so what is the x value? 0. What's the y value? So what's 0 divided by 1? 0. So it's going to do all right. Again, looking at this, it's split up into quadrants. This is quadrant 1, quadrant 2. In quadrant 1, right in the middle, 45 degrees, what is that going to look like? Positive or negative 1? What about quadrant 2? So cotangent is actually going to start with an asymptote and go and be decreasing. So I'm going to write this over here. Start at center or origin. Increasing. Cotangent start with asymptote ends decreasing. All the while, let me ask you guys, what is the period length of the parent function of sine and cosine? 2 pi. Look at tangent and cotangent. From start to finish, what's the distance there? 1 pi. So that means that the period is equal to pi over b. Tangent and cotangent have a period of pi. Sine, cosine, secant, cosecant all have a period of 2 pi. Caleb, you good? You're good. Are you writing anything? Yeah. Okay. So, period. So remember that, guys. The difference between tangent and cotangent is a lot of things. The most important thing is the period length, okay? So make sure that gets established there, all right? We're going to skip the next one, and we'll move on to the next page to look at some examples. Manolab's Wing or Jake Knight?
I know Jake.
You rolled your eyes out.
My name's on that board.
It is.
They probably don't see it. Jake in there?
It did. Alright guys, so let's look at tangent of 2x. First we'll go through all the questions we've talked about before. And we see that, there we go. We see that we're looking at 2 is located here. So our period now, again, it's changed from 2 pi over b. Since it's tangent and cotangent, it's going to be pi over b. Well, in this case, it's pi over 2. The amplitude is a number in front, which is 1. Phase shift is treated treated the exact way that sine and cosine are. So if it says in parentheses plus pi over 2 or minus pi, you'll do the opposite. So plus pi over 2 means left pi over 2, minus pi means right, the distance of pi. But there's nothing in the parentheses here, right? So at phase shift, there'll be none. And vertical shift is just a trailing number on the end, and there isn't any. So in order to write this, guys, again, tangent starts with it being at the origin. So there's no shift up, down, left, or right here. So the good news is we can go ahead and put a dot right in the origin. We can do that no matter what. because there's no shifting up, down, left, or right. So we start here. Now the question is, well, how far do I need to go in order to make my asymptotes? Well, guys, the gap in between the asymptotes is going to be your period length. So what is the period for this one? Pi over 2. So we're going to have fun with fractions today. And the fact is, I can't just say, let me go pi over 2 and put it here, and pi over 2 here and put it here. Because what's the problem with that, guys? Don't write this, guys. Don't write it. Sorry. Tell y'all, don't write this. Because what's the problem with this? What is now the gap in between here? It's the pi. I don't need pi. It needs to be pi over 2, right? So what do you think we need to do with this distance? It needs to be actually inward by how much? By half. Did you say one movement over? But it needs to be by half. Which means this needs to be pi over 4 and pi over 4. Okay? So we got a smaller gap that we were working with here. And so here's the deal now too is we have to come up with 2 more. So guys, in sine and cosine, I worked with you and we made 5 points. Start, stop, middle, and then in each quadrant, right? There was start, stop, in the middle, and then in between each one of those. We made 5 points. For tangent and cotangent, you're doing 5 things. However, 2 of them, this and this, is your asymptote. Asymptote, asymptote, points, and center. Okay? So there will be 3 points and 2 asymptotes when you're doing tangent and cotangent. Okay? We have down 2 asymptotes. We've done the 1 point in the middle. And now let's go and figure out where these 2 points are. Are they going to be here or are they going to be here? Well, tangent, is it increasing or decreasing? Increasing. So it goes there. Now guys, I only went up one line and down one line because what's the amplitude? It's 1, so you only have to go up 1. That's it. You don't have to repeat any more period. That's 1. 1 is good enough for me, okay? Well, let's go on to number 2. The period again. Pi over b, which is pi over 1, which is pi. Amplitude, this one changed. It's 3. Phase shift, none, none, N-U-N. Okay. Vertical shift, N-O-N-E. Okay, this one's an N-O-N-E. Make sure I get the right none right. It's all the same. Nuns are none? Careful, man. It's tough, man. The day and age of PC, you got to be careful. Because what was it? It's Cavaliers coach? Is that who it was? Got in trouble for telling his players they're playing like thugs? Yeah. Yes.
About what he said about Lamar Jackson.
Yes.
Football points into his skin. It's hard to see him like hold the ball.
Yeah, that's pretty bad. To me, thug thing, I don't know. Like, sometimes we can be sometimes a little sensitive. Well, that and it's saying it's racist. It said you guys were playing like thugs. Well, that's what he came back and said. No, I meant to say slugs, like sluggish. They're playing slow. It's like, it's a reach. Whatever. I don't know, man. I don't know. All right. I won't go down that slippery slope. I'm gonna get in trouble. All right. So let's go ahead with tangent again. There's no shift up, down, left, or right. So we are going to start in the origin. We do need to make our asymptotes with a gap of pi. So how far should I go to one side? Half of pi. How far should I go to the other side? another half of pi. Guys, when you do this, as soon as you write your asymptotes, just take a stop for a moment, look back, and make sure that gap is that period. Okay, don't go out here, down here, and all of a sudden you're like, yeah, that's 2 pi. Nope, that's not right. I've done something wrong. I got to bring things in. I've seen that mistake done a lot. Okay, for there. All right, so now let's go ahead. 2 asymptotes, 1 center dot. Now we need 2 more dots in between the dot and the asymptotes. Tangent increasing or decreasing? Increasing. However, what's the amplitude? 3. So I'm not putting it here. I can do it. I'm not putting it there. I'm going to put it 1, 2, 3. Wait, it's increasing, isn't it? Yep, that works. Okay. And there as well. Yep. Pretty steep line, and it might almost look like... Well, it's not pretty, but it works. You get the idea. All right, tangent. Cotangents. Cotangent tends to be a little bit easier because with tangent we started in the middle of a period pretty much, in the middle of asymptotes, which means you had to go half distances out left and right. Good thing about cotangent is you start with the asymptote. And the period is how far you go over along the x-axis to put your new one. So it'll be a lot easier in this case. So we go through, the period for this one is pi over b, which is pi over 1, which is pi. Amplitude of 2. None for phase shift. None for vertical shift. So we go ahead, and as I said, it is cotangent. So the good thing is, since there's no shift left or right, up or down, we can start on the y-axis. Which up and down shift wouldn't affect this, but that's fine. And then how far do we go over, guys, to put our next asymptote? In the middle is going to be our center. Your middle dot's in the middle. And then we go ahead and say, all right, now, cotangent, is it increasing or decreasing? It's decreasing. So we go left and up to, and right and down to make a decreasing pattern. We good? So far, so good? All right, let's move on to number 4. Period. I know you guys, please don't cut this short. I want you to guys write the equations down because I want you to get repetition on this. It is pi over b, which is equal to pi over 1, which is equal to pi. Amplitude, well, there's nothing in front, so it's 1. Now, guys, let me stand corrected up here for just a moment. If you look at this and the 2 tangents above, is there a maximum value and a minimum value? No, because what is at the very top and very bottom of this graph? Which means that it goes on infinity both ways. So when we talk about amplitude, guys, be very careful with the phrasing of this. Cotangent and tangent actually do not have an amplitude. They don't. Amplitude, by definition, is the maximum value of your trig function curve and the minimum value of it. Well, that does not exist here, so therefore, amplitude, though we cue it up in that type of question, if it comes up, cotangent and tangent do not, and actually secant and cosecant don't either, but they do not have an amplitude because they go on to infinity in both directions. However, we use that phrase as its vertical stretch. Okay? It has a vertical stretch of 1, it has a vertical stretch of 2, or so forth and so on, okay? So just be careful because we are answering the question with a number. Just realize that technically it really doesn't. It just helps us guide how it should look. Okay, any phase shifting here on this? Right. Pi over 2. Any vertical shifts here? None. So let's go ahead and start this out. So as we did before, guys, with cotangent, pretty much the same thing with tangent too, is we got to start somewhere. Well, with cotangent, you're starting with an asymptote. And if there's no transformations, it starts at the y-axis. Well, is there any transformation here that's going to affect that? We have a right pi over 2, which means that this asymptote that used to be here is not there anymore. Now we've moved to the right, so this is our new starting points. How far do we go over, guys, until we have our next asymptote? It's a half plus 1. 1.5. What is that as an improper fraction? Yep. I want to put a dot here, guys. Is that okay? Why is it okay to put a dot right there on the x-axis? We didn't do a vertical shift, did we? If I had a vertical shift of up 2, well then that dot doesn't go there. That dot goes up 2, and now we've moved this graph up. You see? We have not had to address this yet because we're talking about asymptotes. Asymptotes only deal with horizontal shifting. Asymptotes does not care about how far up and down we go, because asymptotes go up to infinity to the very top and to the bottom. So we have this thing at the x-axis. Now cotangent, it is doing what from left to right? Increasing or decreasing? Okay, decreasing. What's the amplitude? 1. All right, I'm going to ask you all a question. Let's see. You've seen the two of those now. What transformations do I need to do to cotangent to make it equal tangent? What transformations, by looking at the graph, guys, what transformations need to occur in order for them to lay right on top of each other? It can happen. Give you a few seconds, guys, I'll give you a minute or two to go through and look. And just, hey, if you don't know it all, that's fine. Just see if you can pick something that needs to happen. There's something at the very beginning that's pretty obvious. I've asked that question to you numerous times, and you've answered it. There should be something at the very beginning of it that's pretty obvious, and from there it gets a little bit tricky. Okay? So, go ahead, guys, and see what we need to do to add.
To the power of -1.
We'll get to that. Now, you're talking about the equation. You're talking about reciprocal, inverse of it, right? But what about the graph? What transformations can we do to the graph to make them look the same? You're right, we could do inverse cotangent is tangent. He's right.
Are we looking at a specific one, or just in general?
Just in general. Look, I'm looking at the parent function of tangent. What do I need to do to the parent function of cotangent to make it equal the graph of tangent? And what would be easier for you guys if you look at the very first, when we first graph tangent and cotangent. When we first graph tangent and cotangent, look at those two and think of some things that we need to do in order to make it match. Do we need to stretch or compress it any? No. Do you need to flip it? I've been asking you guys. Parent function of tangent does what from left to right? Increase or decrease? It increases. Then when I asked you about cotangent, you said it does what? It decreases. So one is going from here going up, the other one's starting from here and going down. So what I need to do is I need to flip it in order to make it. So the first thing I'm going to do at the very beginning is I'm going to go ahead and put a negative in front. So negative cotangent. Do I need to change its period length? Because what's the period of the parent function of tangent? Not 1, but we use a different measurement. Pi. What is the period length of the parent function of cotangent? Pi as well. So those are both the same. There doesn't need any type of, so nothing needs to go here, so that's gone. So from here, we have the problem is, we said it. Nice thing about cotangent is we start with an asymptote. The bad thing about tangent was or the good thing, I guess you want to say it that way, we always started in the middle of it, right? We always started in the middle. We always put a dot for tangent, we put a dot right in the origin. And we were technically starting in the middle of the graph, is what we were doing. So we went through. So the deal was, is what do I need to shift left or right in order for make it to lay on top of each other? Pi over 2. If I take it, I flip cotangent and move it left or right, pi over 2, you have the exact same graph. And I just go over that, guys, just because I want you to get familiar with the difference between tangent and cotangent. Sometimes that question comes up. I've seen it before. It might be on your homework. I can't remember if I picked that one or not, but it's around there somewhere. All right. Secant and cosecant, skip all those. All right, so let's go to the table. Well, we just established that. Tangent has the period of what? Well, I don't want green. I'm going to say pi, but in parentheses I'm going to put pi over b, because that's the equation we do in order to graph it. But pi over b is what we use to graph it, that it is pi. What is the amplitude? It's 1, but guys, we've always said it, I told you, it does not exist. Amplitude does not exist. This next part, not the biggest fan of, but we'll make it work. Okay, guys? Domain. Well, let's think about domain, guys. Look along the x-axis. Are we skipping anything along the x-axis? The asymptotes. How often are they located, guys? Every pi. So I'm going to put at the end of this equation plus or minus k, which is any number, times pi. So I could sit there and say, oh yeah, I'm going to have an asymptote here and every other pi. By writing plus or minus k over pi, you've established the every other pi. In tangent, guys, where does it first start? Where is our first asymptote, guys, when you look at the graph? Is it at 0? Is it at pi over 2? Is it at pi? Where's the parent function? Pi over 2. If you look at the graph when we first did it, you'll see a dashed line going through pi over 2. So let me tell you what this says. This says domain. It exists everywhere except x cannot equal pi over 2 and any factor of it. So pi over 2, 3 pi over 2, 5 pi over 2, I can keep going on, 7 pi over 2. Every time you go to those over 2's, the odd numbers over 2's, you will have an asymptote. That's what that means. Same thing goes on the negative side. So same thing means you can go negative 3 pi over 2, negative 5 pi over 2, and that's why the plus or minus is there. All right, range. Well, how far up does it go? Infinity. How far down does it go? All real numbers for range. Let me ask you this, guys. Moving to the next column, what will look the same? Everything except? Does domain start at the same place? Does the graph for tangent start at the same place for cotangent? No. So this will be the same. This will be the same. This will be the same. Where is the first asymptote for cotangent? 0. And where is the first one located? If you looked on the graph, where is the first asymptote located? Y-axis is where it starts. That's good at 0. Where's the next one at? Pi. And it's every pi afterwards, right? So x cannot equal 0 or any version of pi from there. So 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Those will be all asymptotes for cotangent. That's what that means there. We'll get to secant and cosecant later, guys. All right. So for class practice, I want you to go and do 1, 2. Oops. 1, 2. Skip 3. Hang on. Let's do this. What time do we have? Nope, we only got 5 minutes. So you're going to do number 5 only, guys. You're only going to do number 5, please.
Isn't that like a room schedule too?
Guys, make sure you keep it up to your homeworks again on Math Excel, right? Don't fall behind. We got one more day. It will be like finish off secant, cosecant. We'll do the rest of the day for review, and then it'll be test. Pretty quick. Like I said, fast and furious.
Are there 2 assignments on there now?
There are 2, yes. So we have 6.4, and then we have 6.5 day 1, and then we'll have 6.5 day 2.
So this is going to be 3 due,
Yes, ma'am.
including the one that was given last class and today?
Yes, that is correct. So it'll be, like I was just telling them, there'll be 6.4, 6.5 day 1, 6.5 day 2. Only 3 homework assignments.
So,